Okay, back there. Okay, 30 seconds more. Alright, so there's one negative sign. The exponent only applies to the nearest thing to it, because that happens first. Negative sign is really multiplying by -1. Exponent happens before multiplication. One negative makes the whole thing negative. This one, it says multiply -5 by itself. Two negatives make it positive. Okay, now go to C and D, and you can do E and F as well. Okay, 30 seconds more. And let me have you stop. So on C, it means the negative gets repeated 3 times, but that's an odd number of negatives. These two pair up and cancel each other out. One extra negative makes the whole thing negative. This time there's only one negative sign. The 2 gets written down 3 times. We wind up with the same answer. Now, we wind up with the same answer here, but different answers up here, because the exponents were odd versus the exponents were even. When they're even, you'll get different answers for these two. When they're odd, you get the same, because whether there's 1 or 3 negatives, both are an odd number of negatives. Alright, let's look at E and F together. Now the topic on E and F, this is what we're going to go into today in more detail. So if you're uncomfortable with these, we're going to go into why it is that these work this way today. So the least common denominator. You have to have common denominators when you're adding or subtracting. LCD is 8. So we're going to get -1/4, leave some space, plus 3/8. Then we say, what is it that you have to do to this 4 to become 8? You multiply it by 2. So you multiply the bottom by 2, you multiply the top by 2. And so this, with common denominators, is -2/8 plus 3/8, which is positive 1/8. And then when we multiply two fractions, you just multiply the tops, multiply the bottoms. And there's only one negative sign, so the whole thing is negative. 3 times 1 is 3, 8 times 4 is 32, and that doesn't reduce, so we just leave it like this. Alright, so if you all will give me feedback on these 6 problems, You can put nailed it if you got all of them and you're really understanding everything. Still working on it. And if you're still working on it, tell me where you're still working on it, and type in your feedback, but don't hit enter yet. Let me get all the feedback at one time.
Robert, this is Randolph.
Yes.
Let's see. One of my group members, Alondra Silva, she's having a hard time hearing you. And also, she just wanted to let you know that she has to leave class early.
Okay, thank you for letting me know. And I'll try to speak up a bit more then. Thank you.
She might not be able to hear you at all, I'm not sure.
Okay, so maybe it's not my volume, maybe it's her connection. Okay. And Alondra, if you can hear me, try getting out of Discord and coming back in. Sometimes that helps. Okay, so let me go ahead and hit enter, and let me look at the feedback. Alright, thanks for the feedback, and let's go to, let me have you do these next group of 4 problems here. G, H, and then number 2, A and B. Thirty seconds more. And don't rush your way through these. If I don't give you enough time, don't worry about it. Just it's all right. All right. So on G, the least common denominator is 8. And notice it's the same, negative 1/4 or 1/4 and 3/8, and we're combining them in different ways. We're subtracting them, adding them, multiplying, and dividing them. And so this one, this fraction already has the right denominator, so no need to modify it. Got to multiply top and bottom by 2 over here. Okay, so I want to point out something on this. You may have learned when you were in a previous math class to do something like this. And this is okay. If you're comfortable with this, you can keep doing that. I want to explain why I like to do it like this, though. Because it keeps everything in the same line this is equal to this, and this is kind of like going, and then you kind of, adding, and it can easily get mixed up and very complex when things get more and more complex. This keeps everything in the same line. And generally when I do math, I like to have two writing instruments, like a pen and a pencil, something like this, so I can see what I'm inserting, such. Alright, so over here, -1/4, copy, dot, flip. And then before I can multiply and then reduce, but it'll go faster if I reduce first. And that's my answer here. Okay, now when I'm multiplying a fraction times something that's not a fraction, I have to turn everything into fractions. When you're multiplying, you don't have to get common denominators. Four divided by 2 is 2. I could have skipped this step though and done my cancellation before multiplication, and I'd have gotten a quicker answer. I'll do that on this one. I'll cancel first, divide by 3, divide by 3. And that's it. All right, some feedback on those 4 problems. You can type it in, but don't hit enter yet. If you got them all, give me nailed it. Otherwise, still working on it, and then tell me where. And you can always give me extra details. Even if you nailed it, you could say, I wasn't sure about this one. I really needed to review on this, so on. Okay, you can go ahead and hit enter. And let's look at the feedback. Alright, let's do the next set of 4 of these. So CD and AB. Okay, 30 seconds more. Alright, so here. And there's nothing that can be reduced. The only thing you do is you get 5 halves. Now you can state the answer as 2.5 or 2.5. There's alternate notations, but 5 halves is just fine. And then this one, we have to distribute this This is the distributive property of multiplication, and notice it's going over either addition or subtraction, which is the case. 2/3 times 6x over 1 minus 2/3 times 3 over 1. And then I'm going to reduce. They don't have to be directly above each other, just any from the numerator, any from the denominator. So I'm going to get 4x minus, the only thing left over here is 2, and that's it. Right. Eventually, you're going to work on this and be able to do these problems, hopefully, in your head, where you take the 2/3 and mentally distribute it to the 6x. And mentally you'd say, 3 is going to cancel, I'm going to get 2x. 2x times the 2, we're going to go right to 4x. Distribute the 2/3 over to the 3, see that the 3's are going to cancel, I'm going to get minus 2. So eventually, it'd be great to be able to go from here all the way to here and to do this stuff just in your head. Alright, and then this one, 8 plus 7 is 15 times 2a minus 3a. Now, I put this to show what not to do. It's a really easy mistake to make. We want to put those together, but this 7 is being multiplied by this 7. Multiplication happens before addition. So it's got to be this way. 8 plus, when you distribute the 7, you get 14a minus 21a. If you did it that way. Another way you could have done it is I could have just said 2a minus 3a is subtract, it's negative 1a. You don't have to write the 1. Alright, if we did it this way, you're going to get 8 minus 7a. If we do it this way, we get 8, and then we combine these two like terms. 14a minus 21a. You don't get a squareds or anything like this. That was a topic of last time. You get minus 7, and then the a just tags along. Okay, either way, we get 8 minus 7a. A couple different ways we could go about doing it. Okay, and then let's go for this one here. I drop this parenthesis. To drop the second parenthesis, I have to distribute. Now these two are like terms, and these two are like terms. Those 3 y's are going to cancel each other out. All you're going to get is 7x. That's 1x plus 6x, 7 of them. Alright, give me feedback on these 4. Please type it up, but don't hit enter yet. Hey, everybody can give me some kind of feedback here. Go ahead and hit enter. Some comments about B. Anybody else having connectivity problems, like computer keeps freezing, etc.? Can't hear my voice, whatever.
Did your screen just freeze?
Mine's doing good, but we're getting.
Anybody home?
Hey.
Oh, sorry.
Okay.
I'm looking for a rake.
A what?
A rake.
Okay. You want to go in the garage? Yeah. All right. So I had to go back in 3 years. Like 5 people or so having issues with it going.
I may have to log in and out just because the screen just froze.
Ah, okay.
Yeah.
Complete black. Ooh, yuck. All right, and if it gets really bad, you know, abandon the live session and just go and, you know, watch the video later on. A couple hours after class, I'll post the video. And then you can just, you know, watch the video as needed as well, because you might find that, oh, I'm okay with, you know, doing most of the homework. I understand.
How do you watch the video? This is Amalia. Sorry, I don't know. How do you do that?
How do you watch the video? Okay, let me show you. So, you go into the modules. And the very first thing you're going to see is class videos. So here is yesterday's video. Click on it. And then I just hit play. And can make it full screen.
Is this in comments?
Give me a little feedback on part 1, A and B. Okay. So the last 2 or 3 days, you know, I've been getting feedback that a subset of students, typically 3 or 4 students, are having connectivity issue. All right. All right. Let's go back here. So, all right, 2 more practice quiz problems. Go ahead and do these 2. Okay, 30 seconds more. Okay, let's look at C. When we did a similar problem before, we realized we can't put 8 minus 7 together. And one of the quickest way was just to combine these 2 things together. 2a minus 3a is negative 1a. We don't have to write the 1. And then this is two terms. 8 is one term, and all this is multiplied together, so it's another term. So the second term, subtract the negative is the same as adding a positive. And that's it. Number 4 is more tricky than it looks. Negative 2 squared minus 5 times negative 2 times 3. Alright, there's two things that I did wrong here. And let me do them right now. I did them wrong because these are very common student mistakes. The whole thing is being squared. If I write it here, the negative part isn't being squared, only the 2 part is being squared. If I want the whole number to be squared, I have to put in parentheses. The next thing, this looks like 5 subtract, and it doesn't mean subtract. So you put it in parentheses, showing multiplication, times 3. Okay, so this was the part not good. And this becomes 4. This second term is positive because there's a subtracting and negative. And then multiply the first two together. And then 10 times 3, do the multiplication first. And then we're all set. Alright, can you give me a little feedback on these last two problems? Type it in, but don't hit enter yet. Okay, go ahead and hit enter. Seven A plus 8. Yeah, 7a plus 8 is just as good as 8 plus 7a. C was unclear. Okay. Is it clear now, Jacqueline?
No.
Still not clear. Okay. Let me go back to C again. Okay. Good feedback. Alright. So, notice how C and A are very similar. And one more way, one look at this is parentheses means do me first. So if I just did the do me first, and then this is the like terms thing, like 3a plus 2a would be 5a. That was what we did last time, and we didn't get 5a squared. So all we do is subtract these they're called coefficients, the number in front of the letters. Alright, so then this multiplication's got to happen now before the subtraction. And then two negatives make plus, and then you can write it in either order. Do you still have a question there, Jacqueline, or is that?
It's clear now.
Okay, good.
Thank you.
You're welcome. And, alright. That finishes up the practice quiz. So, questions on homework?
I have a question on 60 of 1.6. Me and my group were able to get, let me see, we were able to get what we believe was the right answer, which was 0.01x plus 700, but I'm not entirely sure if we're totally correct.
Okay, you are correct.
Okay.
Do you want me to work it through?
Sure, so I can understand how to get it.
Okay. Alright, so this is 1.6, number 60. The 0 in front of this, 0.08, is optional. So I'm going to leave it off. Okay, so we're going to have to distribute. When I multiply these two together, now I can just pull out my calculator and do it. I can also realize that if I take, let's say, 8 times 10, the shortcut is you take the 8 and move its decimal one place over to get 80. 8 times 100, the shortcut is there's normally a decimal here, but you move it 2 places whenever you multiply by however many zeros are after the 1, that's how many places you move the decimal. So we can think of this as 1, 2, 3, 4 places I'm going to move this decimal. So 0.07, 1, 2, 3, 4, and then it would create 2 more zeros. So this decimal is gone, and then minus 0.07x. So this is really 700.
Mm.
Okay. And then these two are like terms. And so they add together. You subtract those coefficients, 0.01x plus 700. Alright, that's getting used to some decimals, which we haven't really seen much. This one.
Okay. I got it now.
Good. Any other questions?
Yeah, number 69
69.
of the same assignment, 1.6. I get really thrown off when there's multiple negatives and subtraction signs.
Okay. Okay, so the trick is when x is a negative number, there are 2 parts to the x, and when you stick it in there, you very, very often need this parenthesis. And if you don't have that parenthesis, sometimes you're in really big trouble. And it never hurts to put the parenthesis in, even if you don't need it. So that's what makes this go smoothly, is because if I just put negative 5 in there, it's going to make it look like subtract 5. But if I put the parenthesis in there, it's more clear that it's multiplication. And if I just put like this, that would be a really big mistake. Let's go back. But it's a really common thing that students do. This minus is this. I'm going to put this in green to emphasize. That minus sign is that minus sign. The x is negative 5, and it really helps to have it in parentheses. We don't like to put 2 signs right next to each other, minus and negative. So we put a parenthesis. Alright, so then this becomes negative 35, because this is one term, Positive times a negative is negative. Minus 4. This minus a negative is plus. Plus 5 minus 3. And then this is now all addition and subtraction. So we'll just do the left one. And we'll do the leftmost one. Does that clarify? Does that answer your question?
Yeah, thank you.
You're welcome. Other questions?
Number 36, I really got stumped on for some reason.
36. Ooh, that's kind of complex. Okay, so we're just trying to simplify all this. All right. Now, when I've talked about terms in the past, terms are separated by addition and subtraction. I want to throw in one more wrinkle to that. The part that's in parentheses is not a separate term, but you treat it like it's a separate letter, like it was the letter Z. Anything in parentheses means do me first, and kind of like if we knew what Y was, it's the first thing we would do. We'd plug in that number for Y and we'd turn all this into a single number, and like it was the number Z, or the letter Z. Okay, so if we think of it that way, then there's three terms here. This term, negative 10, this term, and then finally this term, plus 3Y. All right. There's not much to do with the first term and the last term. They're not like terms. It's this middle term that we're going to have to get rid of the parentheses. To get rid of the parentheses when there's a minus sign in front of it, you can do it like this. How come the minus sign goes with the 2? Let me show you. Remember, negative or subtraction can also be the same as plus and negative. So when you see it as plus the opposite, then it's really clear that the negative sign and the 2 have to get distributed to everything. All right, now this is, remember when I said we're going to eventually be able to do this in our head? Let's try doing this one in our head. If I take this, remember I got to make it a fraction. Distribute it to the first one. Negative 2 times 1/2. The 2's are going to cancel each other out. There's only going to be one negative, so it'll be minus 1. When I distribute this to the next fraction, there's going to be a negative and a negative. It's going to make, count them up, there's an even number of negatives, make positive. The 2's will kill each other off. So I get 3y plus 3y. Okay, and then I'm going to combine these two like terms. Combine these two like terms. Negative 11 plus 6y. And that's it. Does that answer your question?
Yes, thank you. I really appreciate that.
You're welcome. Anything else? Any other questions? Yes. All right. there's no more questions, we're about at break time. So let's start again in 15 minutes, 1:27 p.m. I'll see you in 15. If you need to talk to me, you can grab me real quick here before I leave. Yeah, anybody else lagging, disconnected now?
Yes, it's lagging. I'm still connected, but it's lagging.
Okay. About 5 people. Okay. On speedtest.net, it says my ping is 28 ms. My download speed is 134 mbps, and my upload is 7.71 mbps. Students are complaining. Is the upload speed okay? All right, we will start again, and our topic today is operations with fractions. And first thing we're going to do is, let me double check that I unmuted my mic. Yep. Topic 1, adding and subtracting fractions. All right, and we've been doing a bit of this, kind of jumping the gun with the practice quizzes, just trying to refresh you a bit. But what we're going to do is we're going to suppose that we're in charge of making the rules for how math is done. And let's say the government came to us and said, you know, math has been such a difficult topic for so many students. Can you simplify the rules, make the rules nice and easy on math so that it's just not so hard? And one thing that's in particular is difficult for students is adding and subtracting fractions. Can you just make it a bit easier? And we say, all right, let's do it. We're gonna do fractions this way. We're gonna say 1/2 plus 1/4. We'll just say, hey, wouldn't it be a lot easier if we just add the top numbers and add the bottom numbers and do away with this you have to get common denominator stuff? Let's just say that this is the way it's going to be. And we tell them, okay, go back to all the schools and tell them this is the way you add fractions, and kids will have a whole lot easier time with math. Now, we do this, but then we wind up having these situations. The next day, we get a text from a kid who said, all right, I have 1/2 of a dollar plus 1/4 of a dollar. Now, and the kid says, I know that this is 50 cents. And this is 25 cents. And I used your method, and I got 2/6 of a dollar. And I analyzed this 2/6, and I said, well, 2 is to 6 as 1 is to 3. So this is the same as 1/3 of a dollar. 1/3 of a dollar is 33 1/3 cents. But I know that when I add 50 cents and 25 cents, I get 75 cents. So what we've just done, we tried to simplify things, make things easier for people with math, but we made nonsense. We get answers that don't work. 2/6, well, look at 2/6 is 1/3. That's smaller than 1/2. We added a positive to 1/2, and we got something smaller than 1/2. All right. Now, we think about this, and we think about, so this is with money. Alright, so let me just put, this doesn't makes sense. Alright. We think about it in another way. Let's have pizza. We got half of a pizza plus 1/4 of a pizza. Now, that means suppose we ate half of a pizza, and then we were at a party, and then later on another pizza came around, and we ate 1/4 of this pizza. And we know that we have totally eaten 3/4 of a pizza. That makes sense. So we know that we've got to get three-quarters as our answer. And we look at this and we start to make some sense out of why it is that when we add fractions, we have to get common denominators. Let's look at what these two numbers mean right here. The 3 represents the number of pieces. Oops. Number of pieces I choose. Now, when you choose them, you chose them and you ate them. The 4 does not represent the number of pieces that I chose. What it really represents is how the pizza was sliced. Into 4 identical pieces. The top number of a fraction is actually a concrete thing. It's how many of those things that you have. But the bottom number doesn't represent how many things that you need to add to with something else. It's just how the pizza was sliced up in the first place. And this gives us this really big insight that why it's wrong. Now I can go in and shrink this a little bit. Y 1/2 plus 1/4 is 2/6 is wrong. It's because we had different size pieces. You're adding one huge piece to one much smaller piece and then saying, oh, that's 2 pieces. Yeah, it's 2 pieces, but as far as a ratio of how much pizza I ate, it's all screwed up. Because these 6, 4 of them are tiny pieces, 2 of them are giant pieces. And then this is one small and one big, and then this ratio tells you nothing that's meaningful for us. We have to have same size pieces for this to work. And this is why we have to do this problem this way. When we take 1/2 plus 1/4. We've been doing this little thing in the practice quizzes, least common denominator. We look at the two numbers and we say, what's the smallest number that both of them will divide into evenly? And hopefully it's just the bigger of those two numbers. If it's not the bigger of the two numbers, like if it was 1/2 plus 1/3, then the bigger of the two numbers is not the one that they divide into evenly. If it's not that, you don't look at multiples of the smaller one, because it'll take you longer to get it. Look at multiples of the bigger one. So you multiply this, 3 doesn't work, but 6 does. And if you were looking at multiples of this, you'd have to go through 2, 4, 6 before you got it. So you take multiples of the bigger one until you find one that both of them divide into evenly. Alright, so we come over here, let me do that. Didn't quite get rid of it all. We say the LCD, and then we do this thing where we say, alright, we gotta get a common denominator. This one already has the right denominator, so I don't need to modify this fraction. This fraction, I'm not allowed to add 2 to top and bottom. The only thing I'm allowed to do is multiply or divide. And this time I need to multiply by 2 to get the right denominator. If you multiply the bottom by 2, you multiply the top by 2. Now, what are we doing to the pizzas when we're doing this? When you multiply top and bottom by 2 to get same size pieces, it's as if you're imagining this piece was also cut into 4 pieces. So now we have same size pieces. This is 2/4 plus 1/4. And then, now, the other huge question, a lot of people never really understand this, is how come once you have a common denominators, you don't add the bottom numbers, you only add the top numbers? It's like to memorize this rule, but never really sure why this is true. Because remember, the bottom number is not representing a number of pieces that you ate or that you chose or anything like this. The bottom number is just how the pizza was sliced. We just made sure that both pizzas were sliced the same way. The top number represents how many you chose. You chose 2 pieces out of this, you chose 1 piece out of this, so you have 3 pieces altogether, and that's what we get. That's our final answer there. Alright, so now this isn't just with pizzas, this is with anything. Suppose your a rich relative dies and there's only a few people who get the money, and you're the one closest related and you get 1/2 of the money, and their cousin gets 1/4 of the money, and then you say, well, between the two of us, how much of the big inheritance did we get? You put it together, and you're dividing whether it's a pizza, whether it's money, whether it's dollar bills. You've got these fractions of them that all work the same way. How many piles are you dividing the money into? And then you gotta have equal sized piles of money before you can add the fractions together, and then the 3 piles out of the 4 piles of money. like this. All right, so I've talked for kind of a while. What would be really useful information for me is if you could go into the chat, the main text channel, and tell me if this filled some gaps for you, or if you already knew all this. And if you already knew all this, that changes the way I teach in the future when I teach this class. But if it filled some gaps and added some extra understanding that you didn't have before, well, let me know. Okay, type that up and then hang on for a second before you hit enter. And then go ahead and hit enter. You don't have to just make me feel better with a good review, because I just need to know. All right, still lagging on the connection. All right, so I'm going to have everybody, will you do the following thing with me, and then type in how fast your download speed is. Okay, so go to your browser, doesn't matter what browser. Go to speedtest.net. So you can see what it is. Speed, that's PEEDTEST.net. And then when you hit enter, it'll automatically run a speed test. And you gotta wait for a little bit. Oh, you gotta hit the go. Go ahead and hit go for your speed test. And then you gotta wait. And the thing that you're gonna need to be interested in is not your ping, not your upload, but your download speed. How fast is your download speed in megabits per second? And see, it took a while for that to come up, and then it'll, for me, my upload speed is relevant, but for you, it's not. And I just was texting my son, who's really into computers, and he was saying that my upload speed should be fine for this. It's your download speed that's a big deal on this. So once you figure out your download speed, come back and type it in the text channel. Let's see what your download speeds are. See if those of you that are having difficulties with the connection, see if it's because of your download speed. Alright, so Freddie, yours is much lower, so that might be your issue there.
I had no idea.
Alright, so let's keep going. And so that was the first topic, which was adding and subtracting fractions. Second topic today. Multiplying fractions. By the way, I was telling my wife and my son, I think it was just yesterday, that I remember an elementary teacher that was, I think it was way back in like 3rd grade, that was just a fantastic teacher. I remember in many of my classes feeling like the class was really chaotic. There was just too much noise, everybody going in different directions. That was the one class where it didn't feel chaotic. It was really calming and comforting being in this class. And the woman teacher, she was just incredible. And I remember doing things like multiplication, and that she had egg cartons and showed us the rows, and that multiplication was adding like all these rows together. And I remember just this sense of wonder of, wow, oh, I never realized this. And I really started to understand that there's a way to visualize, these basic operations. And I think one of the reasons why I'm a math teacher today is that 3rd grade teacher that I had that gave me such a great foundation. All right, so multiplying fractions. Let's look at this. What is what is 1/2 of, and we're going to do a number, almost there. What is 1/2 of 10? Well, we know half of 10 is 5. Nice and simple. What's 1/2 of 6? Oh, that's super easy. It's 3. What's 1/2 of 1/4? Alright, so when would you have to do half of a fourth? Well, like if you are doing a recipe and it says put 1/4 cup of honey in your recipe, but you're only making half a batch. Maybe this is for pancakes or something. And so you need to do half of 1/4. Well, you might look on your cup. Here's my cup. Here's my handle on the cup. And on the edge over here is the markings. This is 1/2 of the cup. 1 full cup. And if you cut this in half, it's 1/4 of the cup. 1/4 means you divide from bottom to top into 1, 2, 3, 4 equal parts. This would be 3/4, and then 4/4 is the same as 1. And then half of the 1/4 we can see would be here. But that's what we get if we divide into 8 equal pieces. 1/8. This next one would be 2/8. But notice how that reduces down to 1/4. Divide top and bottom. And then here's 3/8. 4/8. But that reduces to 1/2. There's 5/8. 6/8. 7/8, and then 8/8, which reduces to 1. And so this seems really clear that it's 1/8. You can visualize this. Now, when we do multiplication, and if we said, all right, let's make multiplication as easy as we can. 1/2 times 1/4. let's just multiply the tops and multiply the bottoms, and let's not worry about common denominators. Do you get the right answer? Yes. Every single time you'll get the right answer. Now, you don't need common denominators. When multiplying fractions. Okay, now let's suppose you got common denominators when you didn't need to. Anyway. Would we still get the right answer? So, go to your chat, your group for today, well, the same group you go to every day, and type in either yes or no. Don't think about it very long. Just what's your instinct? What if we got common denominators anyway, and then we multiplied? Would we get the right answer, or would we get the wrong answer? Now, it might, if it simplifies to the right answer, then we say that's the right answer still. But what if we got common denominators when we weren't supposed to? Would we get the right answer or not? Go ahead and type in either yes or no. And let me give you a moment. Go ahead and hit enter as well. And let me ask group 2, what's your majority answer? Yes or no?
Hello, this is Amalia.
Hey, man.
We answer both, no and yes.
So you had some yeses and some nos. Okay, so it's not clear. What if we got common denominators? Let's go ahead and do it. Let's take 1/2 times 1/4. Now, you don't have to get LCDs for this. Suppose we did. The least common denominator between 2 and 4 is 4. So, this one, we're going to multiply bottom by 2 and multiply the top by 2. So I would get 2/4 times 1/4. Okay. Now I'm going to multiply. Even though I didn't have to get common denominators, I did. 2 times 1 is 2. 4 times 4 is 16. Now when you have 2/16, you need to reduce it. Final answer is always a reduced. Divide top and bottom by 2, and that becomes a 1, that becomes an 8. Is that the correct answer? Yes, it is. If you got common denominators when you didn't need to, you will eventually reduce down to the correct answer. So it's not wrong to get a common denominator, it's just not necessary. You're just doing more work than you have to. You're building up a fraction. Notice we made this fraction twice as big as we had to multiply top and bottom by 2. And then later we had to divide top and bottom by 2 to reduce it. The thing that we multiplied by eventually had to be kind of undone later on, but it'll get us right back to exactly the same answer. Alright, so addition and subtraction, we have to have common denominators. And then multiplication and division, we don't. But if we got them, it wouldn't really hurt us. It would just be extra work. All right. So in this section and on the worksheet, so the homework in this section is going to be 0.2, because it's the name of the section, operations with fractions. There's a chapter 0 in the book. Okay, and the selected problems are there. And if you go in and look in the modules, let me just check back over here too, the different speeds. All right. Yeah. So back in the modules, go to the modules. Oh, let me go home first and get student view. Now the modules. When you go down to here, here's the 0.2, and right after that is this supplement, operations with fractions and using parentheses with exponents. And if I click on this, there's the supplement, and I can click on that, and it'll open up this when you click on that, and that's part of the homework. And the answers are in the back so you can check your work. So that's part of the assignment today. And in the homework, we're going to see problems that have multiple parts. Like, for instance, scroll all the way to the bottom. One divided by negative 2 times 1 over 3 minus 5 over 6. Right. So this is problem number 1. And when we're doing problems that involve fractions that have multiple parts, it's the same kind of thinking as before. Is that multiplication and division has to happen before addition and subtraction. So I've got to do this part first. Do I need common denominators? No, multiplication and division don't. I just multiply them together. 1 times 1 is 1. 2 times 3 is 6. The negative sign can go in the bottom, in the top, or out front. I'm going to choose to put it out front. 2 negatives, though, would make this whole thing positive, fraction positive. Alright, so these already have common denominators. So all I do is combine the numerators. So I'm going to get, I write the denominator once, negative 1 minus 5, which is negative 6 over 6. Final answers that are fractions must always be reduced. So you'll get points off if you give me like 2/8 as an answer. It's got to be reduced to 1/4. It's the same, you know, if you went to Home Depot and said, you know, cut me a board 5 2/8 inches, he's probably going to ask you, well, why didn't you say 5 1/4 inches? I mean, we're used to having fractions reduced. And let's do another one. 2. Negative 2/3 plus 3/8 times 4/3. Alright. This one, let me give you time to work on this. So, get as far as you can on this, and then I'll stop you a little bit. Okay, I'm going to stop you here. Now, this multiplication has to happen before the addition. But, even faster than multiplying first is reducing. Divide by 4, divide by 3, and then I'm going to get negative 2/3 plus 1 times 1 is 1, 2 times 1 is 2. Alright, so I get to this point. Now I have to keep going. Let me give you 30 seconds to get ahead of me on this. If you haven't already done this part. Okay, so here the LCD 2 and 3, take multiples of the bigger one. They both don't divide into 3, but they both divide into 6. So I'm going to have to multiply this one by 2. So as I multiply the bottom by 2, I'm going to have to multiply the top by 2. This one I'm going to multiply by 3. Now notice I'm moving the negative sign from outside the fraction. This should be at the same level as the fraction bar. Outside the fraction over the denominator. Plus 3 times 1 is 3 over 6. Now the reason why I moved it up in the numerator is because now I write the denominator once and combine the two numerators. Negative 4 plus 3 is negative 1. I can write my answer like this, or I can write it with the negative sign at the fraction level. I tend to prefer it like this. Negative of 1/6. That's my total answer. Okay. We have to do another one. It takes a bit to get used to the complexity of all the rules of fractions, plus the order of operations, plus the rules of positive and negative numbers. All of these things come into play in these problems. Let's do negative 1/2 squared minus 1/3 squared. Okay, I'm going to give you a little bit of time to start that around. Okay, when I write this out, it's negative 1/2. It's multiplied by itself, like this. The 1/3 gets multiplied by itself. But notice, this subtraction sign was not being raised to a power, so that only occurs once. So there's not two negatives over here like there is over here. So now I multiply the tops together, multiply the bottoms. But before I do that, I figure out what is the sign of this result. A negative times a negative is positive. So I know it's going to be positive. And then 1 times 1 is 1, 2 times 2 is 4. And then figure out the sign of this is minus. There's only one negative. And then multiply the two tops together, multiply the two bottoms together. And then I need to get my least common denominator. LCD between 4 and 9. Now, in this case, I know it's going to be 4 times 9, which is 36. I don't even have to do the multiples of 9, 18, 27, something like that. I can just go, and the reason why I know it was going to be 36 is because look at what's a part of 4. 2 times 2. Look at what makes up 9. 3 times 3. There's no numbers common to both of those. That's why the result's just LCD is 36. So I'm going to go 1/4 times something minus 1/9 times something. And this needs to be multiplied by 9 over 9 to get 36 as its denominator. This needs 4. So then multiply the tops together, 9, 36, minus 4, 36. And then finally, once the denominators are the same, I subtract the numerators. 9 minus 4 is 5. 36. Okay. Any questions? One last one, and then we're done. Number 4. Change color. Negative 2 to the 4th minus 3 times 2 squared minus 5. I'm going to give you a minute. Get as far as you can in this problem. Okay, let me point out that this is just once. And this is 4 times. So you're going to get 1 negative and 2 to the 4th. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. Minus 3, we're going to go inside the innermost parentheses. 2 squared is 4, minus 5. Now, 4 minus 5 is the same as negative 1. So this is equal to this, which is equal to negative 16 minus 3 times negative 1, which is equal to negative 16. Now this is two negatives in the same term, making plus 3, which is negative 13. All right, that's what I've got for you today. The homework is 0.2, and the worksheet operations with fractions using parentheses and exponents. So, and I'll call it fractions worksheet. All right, and I'm going to remember now to stop the recording.